So what I'm going to talk about now is what would have been our next learning goal in this unit, which is for us to solve a rational equation. Now, rational equations are equations that have variables in the denominator. You actually had a problem on your homework from the other night that was similar to a rational equation, and that was number 11. But in number 11, the variables weren't in the denominator, but you had fractions. Now, if you were to look at expressions and equations separately, you guys would be very, very successful with solving the equations or simplifying the expressions. But when we're looking at them in lessons right next to each other, honestly, they're really easy to get confused. So there's going to be two ways that I'm going to teach you guys to do this problem. I don't care which method you use. I just want you to be accurate. Now, the first method that I'm going to use is probably the one that people are less likely to confuse with expressions. Now, it's probably the safer one. Now, whenever we're adding and subtracting equations, we know that the first thing that we have to do is we have to find a least common denominator. So anytime I have just an integer, I always rewrite it as a fraction just so I remember it's there. Now, when I take a look at these and I say to myself, hey, what's my least common multiple? Well, in this case, my least common multiple is x times x plus 2. So what I'm going to do now is I'm going to rewrite each one of these terms in hopes of getting x times x plus 2 as my denominators. So I have x So this is what I want. This is my goal. So I set it up like that. And then I ask myself, well, if I'm going to play the what's missing game, let's do it. So when I take a look at my first term here, and I've got the denominator of x, but I want it to be x times x plus 2, I know that the x plus 2 is what is missing. So I'm going to need to multiply that numerator by x plus 2. And when I do that then, if I FOIL out this numerator, I'm now left with 2x squared plus 5x plus 2. Well, when I look at this term, I'm now missing an x. So I need to multiply numerator and denominator by x. So then I end up with x squared. And here, I'm missing both of them. So when I go to solve that one, I have 2x squared plus 4x. Now, once I have that done, what you'll see is I now have every single term here has x times x plus 2. So what I could do now is what I'm going to do. And I don't normally write this step, but if I multiplied this entire equation by x times x plus 2, what's going to happen is all of these denominators are going to cancel out. So I'm now left with this quadratic equation of 2x squared plus 5x plus 2 equals 3x squared plus 4x. So now I'm able to go ahead and solve this. So I have it set equal to 0, and now I can factor it. So I have this. But what I'm going to tell you guys is that these are what we would call your proposed solutions. Now, that's because rational equations also have extraneous solutions. Now, I believe that they're a little easier to check for than the others. Now, when I'm looking for extraneous solutions, I really just need to see, will the proposed solutions make my denominator 0? If the answer is yes, they're not a solution. If the answer is no, then they are. So when I take a look at my original equation, well, my denominator is x here, and if I plug in 2 or -1, it's not 0. If I plug in 2, it's not 0, and if I plug in -1, it's not 0. So what this is telling me is that they're not only proposed solutions, they are actual solutions. So this is your first example of solving the rational equations. I am going to show it to you one more time in the next video, a slightly separate way. I'm going to get it started. I probably won't finish it entirely. So stay tuned.